The Floriane Institute from Marseille in France presents different systems to detect moisture and water content in biofuel by online radiofrequency characterization. This method is based on permittivity of material. To understand interaction between microwave and material, the permittivity of a material depends on transmission and reflection coefficient of the incident microwave. If the material is a mixture of a biofuel and impurity, the permittivity changes with impurity if there are a contrast dielectric between the natural biofuel and the impurity. At the Floriane Institute, we experiment different systems based on reflection and transmission coefficient measurement in order to quantify the impurity content like water in biofuel. For liquid biofuel, we focus on ethanol for bioethanol application. The evolution of permittivity every 4% of add water in ethanol has been verified with a coaxial transmission line based on the reflection and transmission coefficient measurement in a sample order of 13 mm of diameter. We did the same things with wood pellet with different moisture content in a bigger sample order of 100 mm of diameter. The moisture content of each sample of wood pellets have been verified with a moisture content analyzer. By these studies of permittivity, both materials have been tested in online system developed for the project. A liquid system to detect the water in biofuel like bioethanol and a solid system to detect the moisture content in wood pellet. The liquid system is a tubular system composed of radiofrequency probes located at the periphery of the material under test. Two openings allow the liquid to flow out during the measurement. The detection of water is based on the transmission measurement between probes. Nowadays, the system is sensitive at 4% of water in bioethanol. The solid system is the upper composed of two print patch antennas. The principle of the online measurement is to perform it before the removal of wood pellet in a conveyor belt. It's only based on the transmission between both patch antennas. Today, the system is still under development and can be sensitive to moisture content for certain frequencies. To conclude, the Floriane Institute focused on two parts concerning liquid biofuels and solid biofuels. In the liquid biofuels, permittivity measurements were performed on ethanol and mixtures. This measurement allowed to test it in an online liquid system of where the measurements have been sensitive at 4% of water in ethanol. In the solid biofuels, we measured the wood pellet with different moisture content. This measurement allowed to test it in an online solid system remaining in progress.